Hello everyone, welcome to Sam Science View channel. In today's video, we are going to listen to a science fact how CFL, that is compact fluorescent light bulbs, work. Before getting into the video, please watch this entire video, and if you have queries related to science facts, you can comment about it and get it rectified through this channel. Now let's get into the video. As the symbol of innovation, the incandescent light bulb is not very innovative. It hasn't changed much since Thomas Edison introduced it in 1879. Even today, it still generates light by heating a tungsten filament until it reaches 4172 degree Fahrenheit, that is 2300 degrees Celsius, and glows white hot. Unfortunately, all of that white light is not very green. A good deal of electricity from coal-fired powered plants responsible for spewing greenhouse gases into the atmosphere is required to make an incandescent bulb burn brightly. Only 10% of that juice goes toward making light. The rest is wasted as heat. Luckily for our CO2 soaked planet, there is a new type of light bulb that stands poised to replace Edison's most famous invention as the icon of ideation. It is known as the compact fluorescent light bulb, or CFL, and its illumination comes by way of a much different mechanism. Instead of a glowing fluorescent filament, CFLs contain argon and mercury vapor housed within a spiral shaped tube. They also have an integrated ballast which produces an electric current to pass through the vaporous mixture, exciting the gas molecules. In older CFLs, it took several seconds for the ballast to produce enough electricity to ramp up the excitation. The present day newer CFLs have more efficient ballast and require a shorter warm up. Either way, when the gas gets excited, it produces ultraviolet light. This ultraviolet light in turn stimulates a fluorescent coating painted on the inner side of the tube. As this coating absorbs energy, it emits a visible light. Believe it or not, CFLs are the descendants of the light scarber shaped fluorescent bulbs that still flicker in garages and workshops all over the world. But these are not your father's fluorescent. Despite their heritage and their similarities to incandescent bulbs, they both require electricity, they have a glass cover, they have a threaded base. CFLs are emerging as the biggest thing in interior illumination since the candle. Here we have to see all about the CFLs. It will examine the good, the bad, and the ugly of the CFLs so that you can use them with confidence about it. So, now let's see some of the benefits that come from using the CFL bulbs. The benefits of CFLs have been grabbing headlines for the last 2 to 3 years. Indeed, if you were focused only on the buzz surrounding CFLs, you might think that changing out your incandescent bulbs in favor of their spiral cousins would be a complete no-brainer. As we will see it, CFLs do present some challenges and concerns, but their benefits are far more numerous. First, CFLs use significantly less energy, that is around 75% less energy than incandescent light bulbs, which means these CFLs require less wattage to produce an equivalent amount of light. For example, you could use a 20 watt CFL and enjoy the same amount of light as the 75 watt incandescent. If every home made one such swap, enough energy would be saved in 1 year to light more than 30 billion homes. Of course, if you are using less energy, your energy costs are going to go down. Replacing a standard 60 watt bulb with a 13 watt CFL can save a single household energy cost over the life of the bulb. Even with the higher price tag of CFLs you will pay for a CFL versus 30 to 40 cents for a typical incandescent bulb, they still save your money. That's because CFLs last a long time. In some tests, they burned brightly for 10,000 hours, whereas standard bulbs burned for just 800 to 1500 hours. The environment comes out ahead too. A good deal of electricity coming from coal fired power plants gets directed to the lamp and light fixtures inside your house. If you are saving energy by using CFLs, then you are pulling less electricity from the power grid. This reduces the amount of coal that must be burned, which reduces emissions of greenhouse gases. In a single year, the use of CFLs over incandescent bulbs removes as much greenhouse gas pollution as taking 2 million cars off the road. These would be dubious benefits if CFLs didn't perform well or couldn't be used in many applications, but they are in fact quite versatile. Several manufacturers make compact fluorescent light bulbs that can be used with dimmer switches and in three-way lamps, and many CFL bulbs can be used outdoors as long as the fixture is enclosed. Most importantly, they give off good light. In a 2007 study conducted by Popular Mechanics, CFLs burned almost as bright and produced a better quality light than a 75 watt incandescent bulb. CFLs are not worry free, however. We will see some of the bad things, that is, the drawbacks of CFL bulbs. The CFL bulbs may be versatile, but they do have some issues that put people off. First, they deliver their best results when left on for 15 minutes or longer. Switching CFLs on and off will shorten their life and may decrease their efficiency, mainly because the excitation of the gases and of the fluorescent coating that some exposure to an electric current to reach an optimal level. CFLs are also inefficient in enclosed recessed fixtures, too hot, and in the fixtures of garage door openers, too much vibration. Finally, CFL bulbs can in rare cases interfere with electronic equipment. This interference is caused by infrared light which CFLs produce and which IR readers can interpret as a signal. Now let's see about a CFL bulb and a mercury in it. If there is an ugly truth about the CFL bulbs, it's the mercury they hold within their glass covers. Mercury is a persistent and highly toxic chemical. Most humans are exposed to the poison by eating fish contaminated with methyl mercury. However, it is also possible to inhale elemental mercury vapor like the kind used in CFL bulbs. So why is it there, and why don't CFL manufacturers use something else? As we have said, mercury vapor is required to convert electrical energy to radiant energy. When stimulated by electric current, mercury vapor inside a CFL produces UV light, which is re-radiated as visible light when it strikes the fluorescent compound known as phosphor, painted on the inner surface of the bulb. No other element has proved as efficient in this process. So even though the amounts of mercury used in bulbs has decreased over time, a small amount of mercury is still required for CFLs to function properly. It is important to keep this in perspective. One CFL bulb typically requires approximately 5 milligram of mercury. Older home thermometers contain 100 times that amount, and many manual thermostats contain 600 times that amount. So a single CFL bulb has very little mercury and none of the chemical is released as long as the bulb remains intact. A broken CFL bulb, however, can expose a person to mercury vapor. A tiny amount of solid mercury powder can be released. For these reasons, extra caution should be taken when cleaning up a broken CFL. There are some following 4 easy steps to be followed to be precautioned. First, turn off your central heating or cooling system so fumes aren't moved from one room to another. Then open up the windows and let the room ventilate for 15 minutes. Next, it's time to clean up the broken bulb. Put on gloves to make sure you don't touch any of the mercury powder. Use a piece of cardboard to scoop up large pieces of glass. Switch to sticky tape to pick up small fragments and shards. Don't use your vacuum cleaner and make sure all broken pieces, tape, and cardboard are placed in a plastic bag. Finally, wipe the area with a damp paper towel and place the used towel in the plastic bag as well. Seal the bag and immediately throw it away. This should take care of a broken bulb, and we will see about the CFL bulb, how it burns out. A quick silver lining. The good news is that CFLs, although they contain mercury, actually help eliminate mercury from the environment. That's because mercury is also found in coal. Burning coal releases the toxin into the environment. Energy Star estimates that a coal-fired power plant produces 13.6 mg of mercury to power 160-watt incandescent bulb, but only 3.3 milligrams to power an equivalent CFL bulb. Now we will see how to recycle this CFL bulbs. So we do with a burned out CFL bulb if it contains mercury. First, you should realize that CFL bulbs are considered hazardous household items, a category that also includes paint, batteries, and thermostats. You must dispose of such items properly, which means you can't simply throw them away in household garbage. To find out your options, start by calling your local waste management authority. More and more retailers are stepping up to help with CFL bulb recycling. IKEA was the first retailer to provide free disposal and recycling of used CFLs. The Home Depot joined with them in 2008 by launching a national in-store consumer CFL bulb recycling program in all of its nearly 2,000 locations. Some Ace and True Value stores are offering similar programs for it. As recycling becomes easier, the CFL revolution will only gain momentum. Many think that the spiral shaped bulbs will be a brief evolutionary step toward the even more efficient light emitting diode, that is LED bulbs. A 1.3 watt LED bulb uses less electricity than 9 watt CFL and can last for up to 11 years. Better yet, it doesn't contain an atom of mercury. But even LED bulbs have their trade-offs. They are not very bright and they are exorbitantly expensive. Until manufacturers overcome those two issues, CFL bulbs will likely have the spotlight all to themselves. So, this is what is about the compact fluorescent light bulbs working. So I hope so you got some idea about this CFL bulbs. And if you have any queries related to science, you can ask to me and get it rectified. We will meet in the next Science Fact Treasury series. Until then, it's goodbye from Sam. Take care.